This video will cover operations with rational expressions. Let's just review quickly what is a rational expression. Before we do that, we're going to see what is a rational number. And so a rational number is the ratio of an integer divided by another integer. So when we talk about rational expressions, they will be the ratio of two polynomials. And remember, polynomials could be monomials, binomials, trinomials, and more terms, right? So, for example, here with the 25x, what kind of polynomial would that be? Is that a binomial? It's a monomial. So we know it's a monomial, even though you see two factors in it, they're not separated by a plus or a minus. So that's why it's a monomial. Now, would you guys be okay saying that 2 is a polynomial?
It's a monomial.
Well, it is a monomial, but remember, monomials go into poly. Maybe they shouldn't, but they go. But yes, it is also because it's just of degree 0. Okay? You have a question? No, not yet. Okay. So that is okay to have rational expressions that way. Now, once we are comfortable, we're going to cover the basic operations, which is multiplication, division, addition, subtraction. Once we're comfortable with that, with those, we'll go to rational functions. Okay? And rational functions, I want to find a I have it in one of my books, and actually I forgot the name of it. I'll look it up during the break. But have you guys seen that movie Moneyball? About baseball.
What movies do you watch?
The one with Brad Pitt.
The one with Brad Pitt, yes.
Who is he?
Oh, thank you,
God.
Isai. So anyway, that movie, I think I watched it because it was like, we had like an HBO preview or something. So anyway, that movie is about this baseball team. What was the team for that? Okay, so what they do is like the baseball team didn't have enough money to pay for the good baseball players, the ones that were like ranked higher. So what they did is this very smart guy got a hold of Brad Pitt, who was the team manager, right? And so with math, there's this thing called, I don't know the name, but they calculate the power and the speed of each player. And so based on that, they were able to recruit players that probably were not seen as the best, but they did that because they were more affordable. And so they made this like amazing team with using math. And that was a rational function, actually. So that is one of my plans to look into that problem. It's kind of interesting. And so there are other ways where you can apply rational functions, as you saw in your introduction, that you could be applied to an inverse variation, right? So let's just get to the basic operations now. So when you multiply fractions, you multiply straight across. So if we multiply 25x times 1, we will get 25x. If we multiply 2 times y cubed, we will get 2y cubed. And that's it. That will be the answer. There's nothing else we can reduce or simplify, so that will be it. For the next one, we have negative 7 times 3. So we're going to multiply the coefficient. That will be negative 21. And then we will have x squared y to the 5th. And on the bottom, we multiply 5 times 14. That will be 70. And then we will have x squared divided by y. Now, right here, we can see if there's something to simplify. And we can see right away that 21 and 70 are divisible by 7. So negative 21 divided by 7 is negative 3. And then the x squared with the x squared, that makes up a 1. So we may say it cancels. And then what should I do with the y's? Subtract the exponents, right? So y to the 5th divided by y will be y to the 5 minus 1, which is 4. 70 divided by 7 is 10. 10. And that will be the final answer. So we multiply and then we simplify. question on that? No? Okay. So we're going to go to the next slide. And yes, I do need you to copy all of this. We're going to follow the steps that we have listed here to multiply rational expressions. And you will see how easy this will be. So what we need to do is completely factor both the numerator and the denominator. And then we're going to multiply, and I'm using quotation marks here because we're not actually going to carry out the multiplication. We're going to leave everything in factor form. And you will see why in a minute. Then we simplify, of course, that's the purpose, by dividing out common factors that will equal 1, right? So in this case, we can factor, what do x squared and x have in common? 1x. So if we factor out an x, what am I going to get inside the binomial? X plus 1. Now, numbers, we could also factor them by using prime factorization. So 6 could be factored as 2 times 3. Then here we have 3x, let's just factor as 3 times x. And for 5x plus 5, you can see clearly that a 5 is in common. And if we factor out a 5 from 5x, remember, just in case you forgot, 5x divided by 5, that will be x. And for the other one, we have 5, we're factoring a 5, so that is equal to 1. So we get x plus 1 again. Now after that, we can divide out common factors, so that will be x plus 1 and x plus 1. And I want to clarify something. I've always told you, if you see a plus or a minus in between, you do not cancel. But in this case, we can cancel because we're canceling the whole binomial. So I couldn't just cancel the x and the x, but if I cancel the whole thing, it's okay. All right? As long as they are identical, like x plus 1, x plus 1.
So we cancel 3.
The 3. What else? Yeah. So final answer will be 2 on the numerator, that's okay, and a 5th on the denominator. And that's it. That is the answer for that. So I'm gonna, any question before we move on from this one? Okay, so I'm gonna move on to the next problem so you can copy it down. We're gonna follow the same steps from the previous slide. So we're gonna factor 3x plus 3. The 3 is in common. And we got x plus 1. Now the next one is a trinomial square. So we're going to factor it into the product of 2 binomials. The only way you can factor 2x squared is by factoring as 2x times x. And then what does this mean to have a negative sign here? That our signs in here will be what? The same or different? Different. So here we're going to do a little bit of guessing. But I can tell you this. What are the only factors of 3? 1 and 3, 3 and 1. So I'm going to say that the 3 goes here and the 1 goes here. That's my guess. And then I'm going to say that my signs are going to be positive and negative. But since I'm guessing, I need to check now. So to check, it is enough to multiply the 2 terms that are on the outside, 2x times 1, that is 2x, and then to multiply the ones on the inside, negative 3 times x, and that will be negative 3x. But if we combine them, we get negative x, and that's not what we need, right, for a term in the middle. So what should I do?
Change
The sign? So how do we have them before?
plus 3 and then negative.
Oh.
So I need the plus here.
Yes.
Okay. Now let's check that one. So 2x times negative 1 is negative 2x. 3 times x is positive 3x, so that will be positive x. And so that means those are the correct factors. Now let's go ahead and factor the bottom, the denominators. So for 5x and minus 5x squared, what do they have in common?
5x.
5 and also x, so 5x. And if we factor that, we will get 1 minus
Minus
what? Now, for our next denominator, that is the difference of what, guys?
Square.
Uh-huh. So we take the square root of 4, that is 2. The square root of x squared is x. The square root of 9 is 3. And we make one positive and one negative. That's how we factor difference of squares. And now we can see, is there anything for us to cancel? So the only thing that I see is 2x plus 3 and 2x plus 3. And I know you might be thinking, couldn't we just cancel that with that?
No, because it's different.
It's different what?
The order.
It's -1
You
and
flip it,
negative.
it's technically negative.
Okay, so the order is different, but also the signs, right? And they're completely opposites. So what were you going to say, Aya?
Could you instead back it up to 5x minus 5x.
Yes, we could have done that, factor a negative 5x. But since we already started here, another thing we could do is factor out a negative 1 from here. So we have the 1 minus x. We're going to take out a negative 1. And so remember this. If you have a positive 1 and you factor out a negative 1, it's like you're dividing. So what would that be? Negative 1. So that goes here. Now, if you have negative x and you factor out a negative 1, what do you get? So positive x. Now, that looks almost like that. We just need to change the order. So that could be negative 1 times x minus 1. So that's the one we're going to use. Now, what Aya was saying is, could have we done that from the beginning and make this 5x negative? Yes. We could have done that, and then you don't have to do the steps. But either way is correct. So you may use whichever way you prefer. Now, right here, what I'm going to do, continue the problem. So we have a 3. We have an x plus 1. We have an x minus 1. We have a 5x. We have a negative 1. And now we do have this one, x minus 1. But you notice how I still need to account for this negative 1 that I factored out. You can't just, like, make it disappear. And then the 2x minus 3, of course. So now we can go ahead and get rid of that, and we'll be left with 3 times x plus 1. On the bottom, we could go ahead and multiply negative 1 times 5x. And then we will have 2x minus 3. Now, this answer is correct. It's just the one in factor form. But it is correct. And the nice thing about rational expressions that are in factor form is that you can find the domain if we were talking about a function, which we will pretty soon, whenever you guys are not testing. So we could also do the following to kind of simplify it. So we distribute the 3. We will get 3x. And then 3 times 1, that will be plus 3. On the bottom, we'll have negative 5x times 2x. So that will be negative 10x squared. And then negative 5x times negative 3, that will be plus 50. So this is also the correct answer. It's just not in factor form.
That'd be plus 15x.
Yes. Thank you. So let's move on to the next one. Is there anything else? Anything you would like me to rephrase? No? No? Okay, so let's go to the next. Now, to do the division with rational expressions, we're going to follow the instructions here. And I want to ask you something. When you were in middle school, Do you ever hear someone say copy,
Hey, copy.
Change flip?
change, flip? Okay, so that is not really the correct way to call it. What we should say is that you multiply the first rational expression by the reciprocal of the second rational expression. So that reciprocal, it kind of fits the description of flip, right? Because you're making your numerator the denominator the numerator. So what we're going to do here is that. And before we do that, I want you to leave some space here. So I'm going to solve it down here. And it's going to be, I'm going to copy the first rational expression like it is. And then the second one, I'm going to write the reciprocal of it, so y squared on top, and for x cubed on the bottom. Now, we can follow the rules for multiplying fractions, and we multiply straight across. So that will be a 3 times 3x cubed times y to the 7 y squared. So y is the same variable. We could add the exponents there. We get y to the power 9. Now, on the bottom, we're going to multiply 40 times 4. That's 160. And then we have x to the third power. What we could do here is x cubed and x cubed, they make up a 1. So our final answer will be 3 y to the power 9 divided by 160. Now, I'm going to show you guys another way that this is how I learned to divide. So, instead of doing the multiplication by the reciprocal, I was taught to just multiply in a zigzag.
Oh,
no.
I remember that.
So that will be 3 x cubed, y7, y squared, that's y9. And the other one will be 40 times 4, that's 160, x cubed. Cancel the x cubed, so you get 3 y to the 9 over 160. Okay? So, I mean, you could use whichever way you want. For the purpose of, but while you get used to it, it might be a good idea to just rewrite it as the reciprocal, and then as you get more comfortable with that, you could do that. This method. Same answer. So let's move on to the next one. So to divide the two rational expressions here, I'm gonna just rewrite them by writing the second one as the product of the reciprocal. After that, I'm going to go ahead and factor them. So we'll have x plus 2 times x plus 2 because you're saying that binomial squared. We have 5. 5 is a prime number itself, so we don't need to factor it. 10, we can factor it as 5 times 2. And then for the next binomial, this one here, what do they have in common?
2.
So if we factor out a 2 from there, we will get x plus, what is 4 divided by 2? 2. So we get x plus 2. Now, let's see if we could make up 1 there. So we have x plus 2, 5, 5. So we're left with x plus 2 on the numerator, and the denominator will be the product of 2 times 2, so that is 4. Now let's move on to the next one. Any question on that problem, number 5? Okay, so let's move on to number 6. We're going to do the same steps. Try to do that one on your own, and then we will check. Don't wait on me to write the answer. Give it a try. Either way, so on ours, I will look at the instructions. Okay, I'm gonna start writing my answer so that you could compare it with yours.
It's probably not hard.
Now I'm gonna simplify. If you're still working on it, continue working. Just check at the end. So the two last expressions that you see on the bottom row, they're both correct. It's just that this one is in factor form. But they're both correct. And what I did on this one, I just distributed the x, so x times x and x times 1. Any question? No? Okay. So let's do that one next. All right, example 7, I'm recording now, so I'm going to start it. If you prefer to work it on your own and then check, I have no problem with that.
They're both negative.
They're both negative. Very good, because the sign is positive, so that means both signs are the same, but since this is negative, both will be negative. And the only factors of 5 are 5 and 1. So the 5 goes here, the 1 goes here, I'm guessing. So now I'm going to check. 2x times negative 5 is negative 10x. Negative 1 times x is negative x. So if we add them, it's negative 11x. And yes, that is correct. That's what we were looking for that term in the middle. So those are the correct factors. Now, this binomial here, it has a 5 in common, so we will have x minus 5. And the binomial here, what can we factor out? 2. And so that will give us 2x minus 1. Keep in mind that if you don't know how I get these little numbers, there's nothing wrong with you on some side of your paper, scratch paper, just divide them. 4x, factor out of 2, you divide, and then you will get 2x. There's nothing wrong with that. So, now from here, we have x minus 5, 2x minus 1, 2x minus 1. We have a 2, and a 2, a 5, and a 5. So what is the answer now?
1.
Thank you for not saying 0. It's a 1. Because remember, we say they cancel, but they don't disappear. They're making ones. Every single class I've taught, they have said 0.
Kind of sad.
Okay, so we have time. Let's just copy this one.